have an example here which will help us know how we can determine the resultant of a force using resolution of forces. So a force, these are two forces. One is acting at, so we have to draw, this is what we call the space diagram. So we have y-axis and x-axis. So one force is acting at 25 degrees and its magnitude is 5. It has to be shorter than the other one, so 5 newtons. And you have another force which is acting at 112 degrees and its magnitude is 8 newtons. Now the first step is to resolve these two forces in both the x and the y axis. So direction of these components really matters. So for example, we want to get the horizontal component of this force, 8 newtons. So we have F, so let me name this as F1 and this is F2. So you have F1 cos 112 degrees because this is the angle from the x-axis. So it will be in this direction. And then we have to get the horizontal component of this force, that is F2, in the which will be F2 cos 25 degrees. Same to the vertical. So for F2 we'll have F2 cos 25 degrees, and for F1 we'll have F1 cos 112 degrees. Now you realize that the vertical components of both the forces are in the upward direction, so they'll take positive. And when you look at the horizontal components, one is opposite the other, so one must be negative. Either of these must be negative. So since this part of the Cartesian plane is always considered negative, then we get this as negative. So this will have a negative part, will carry the negative part of it. So we have, so one, add the components of the forces. So let's have FH represent horizontal forces. So when you add the component of the horizontal forces, so you have F2 cos 25 degrees, which should give us 2 point. So let's just add the F. So we have F2 sorry, cos 25 plus F1 cos 2 degrees, 112 degrees. So this part alone, since we know F2 as 5 newtons, so this part alone will give us around 2.113 newtons, and the other part will give us negative no, this will give us around sorry, we have F2, which is 5 cos 25, 5 cos 5 cos 25. This part will give us 4.531, and this part will give us negative 2.997. So when we get the difference, 4.531 minus 2.997, we get 1.534 newtons. And then we do the same to the vertical components. So for the vertical components, we add F1 cos 112 degrees plus F2 cos 25 degrees. So this should give you, so when you work out F1 cos 1, so F1 cos F1 is 8 cos 112, get negative 2.997. Then we have 5 cos 25, we get 4 no, this should be sine. Sine, both of them should be sine. Sorry for that confusion. Sorry. So you have sine, sine. So 8 sine 112 get 7.417 plus f2, which is 5 sine 25, 2.113. So if we add that, we get around 9.53 newtons. Now this is the, so you see this one, this FV will be, so this is FV and it is equals to 9.53 newtons. Now look at this horizontal, the horizontal component. Since this has the larger magnitude, that is, this part has the larger magnitude, the component of F2 in the horizontal direction has a larger magnitude than the component of F1 in the horizontal direction. So it will take this direction. So we have that. So this will be 1.534 newtons. So the resultant will run from here to this point. So we have, this is the resultant force, R, RF, let us have it as RF. And this is the angle subtended in between one of the forces, that is the horizontal component, and the resultant force. So to get the magnitude, we say magnitude, so to get the magnitude, so RF is equals to the square root of, so we just use the hypotenuse theorem, so that we have 9.53 squared plus 1.534 squared. We use the Pythagoras theorem to get RF, whereby you know that this side is opposite and this side is adjacent. So here we shall get around, when you get the, when you work out whatever is in the squared sign, get this is what we get, 93.17. So to get RF will be 9.653 newtons. So that is the magnitude of the resultant force of these two forces. Then we get the direction theta. To get the direction theta, we say tan inverse over, so you have this as the adjacent, so we have opposite over adjacent. So in our case, opposite is this is the opposite, 9.53 divided by 1.534. So tan inverse of that should give you around 80. So theta is 80.85 degrees. So this is the angle between the horizontal and the resultant force. So this is the magnitude, and this is the direction of the resultant force. So you can use this method to get the resultant of numerous coplanar forces. So it might exceed 2, it might be 3 or 4 or 5. So this is the method that you use. First, you get the components in the x direction or the y direction, and then add the components in the y direction in one side, x direction in one side, and then you come up with this vector diagram. So from this vector diagram, you'll be able to know the direction of the forces and now get the resultant force using the Pythagoras theorem and the tan inverse to get the direction. So keep watching these tutorials. Next we are going to tackle moments.